G'day everyone. This rust-coloured planet you're seeing could be humanity's second home in the future. This is Mars, mate. It sits 225 million kilometres from Earth on average. It's got land area equal to 1.5 Earth continents. Its volume is just 15% of Earth's size. But crikey, it towers with volcanoes 3 times higher than Mount Everest. It stretches canyons as long as Sydney to Perth. That's bloody massive. And it hides secrets that might completely rewrite the origin story of life. You might not know this yet. This frozen world at minus 63 degrees Celsius may have had oceans larger than the Mediterranean 3.8 billion years ago. Back in 2015, NASA's MAVEN probe released some pretty mind-blowing data. Current measurements show Mars loses 1.8 kilograms of atmosphere every second to solar wind. This has been happening for 1 billion years, fair dinkum. If we collected all that lost gas, it could cover the entire planet with 20 meters of liquid water. Right now, 3 rovers are working flat out on Mars's surface. Perseverance's drill is extracting clay samples from a 3.5 billion-year-old lakebed. China's Zhurong rover found permafrost structures in Utopia Planitia similar to what we see in Antarctica. Here's something absolutely fascinating. The European Space Agency's orbiter has detected this for 7 straight years. Every northern hemisphere early summer, Mars's atmospheric methane jumps to 4 times background levels. These methane pulses always appear at Martian sunrise, then mysteriously vanish before noon. On Earth, 90% of methane comes from biological activity. But on this planet, where even bacteria struggle to survive, who's making these organic molecules? Are they traces of ancient life buried deep underground? Or geological wonders we don't understand yet? Let's get our bearings first, shall we? A Mars day is 39 minutes longer than Earth's. Your watch would still work there. How good is that? Its atmosphere is 96% carbon dioxide, but density is only 1% of Earth's. This means sound travels weirdly there. If you tried talking to someone, it'd sound like speaking underwater, all muffled and strange. But the most mind-blowing discovery comes from Mars's South Pole. In 2018, Italian scientists used radar echoes to find a 20-kilometre-wide liquid lake under 1.5 kilometres of ice. This water body has salinity levels approaching the Dead Sea. It reminds astrobiologists of Antarctica's Lake Vostok. In that lake, isolated for 30 million years, we found completely new microbial ecosystems. If we drilled life samples from Mars's ice layers tomorrow, how would humanity cope with this mind-bending discovery? If we proved Earth's life originated from Martian meteorites, would we all become descendants of interplanetary migrants? Right, for the next bit, get comfy. Maybe grab a cuppa. Let's see what absolutely incredible stuff Mars has in store. Here we go. To solve these mysteries, we need to go back to Mars's early days. Back then, its sky was brilliant blue. Liquid oceans covered the northern hemisphere. A magnetic field wrapped around the globe like a protective umbrella, until one catastrophic impact forever changed this planet's destiny. About 4.6 billion years ago, Mars and Earth were born together from the solar nebula's dust disk. Newborn Mars had the classic structure, iron-nickel core with silicate mantle. But low gravity made its interior cool 10 times faster than Earth. This planet's fate was sealed from birth, unfortunately. Latest meteorite analysis shows Mars's crust solidified 120 million years earlier than Earth's. This explains why Mars kept more complete early geological records. NASA's MAVEN probe revealed that 4.1 billion years ago, Mars's global magnetic field collapsed in just 1 million years. Solar wind particles started stripping away the atmosphere. Mars was losing atmosphere at 250 grams per second back then. That's like losing a standard swimming pool's worth of water every minute. Absolutely mental. Without its magnetic field, Mars was like an astronaut with their protective suit ripped off. Direct exposure to cosmic radiation. This directly caused surface liquid water to start evaporating and escaping. In 2024, the European Space Agency used quantum computer simulations to discover something massive. If Mars had kept its magnetic field until today, its atmospheric pressure would reach 0.9 bar. That's close to Earth's sea level. The northern hemisphere would have liquid oceans. This study completely flipped our understanding of Mars. Analysis shows Mars lost 99% of its original atmosphere 3.7 billion years ago. The leftover carbon dioxide forms seasonal polar caps. Winter freezes it into dry ice covering the poles. Summer sublimation triggers global dust storms. NASA's Curiosity found evidence that during this period, Mars's water became extremely acidic. That's like the acidic mine wastewater we see in some parts of Australia. This extreme environment forced any potential life to go underground or enter dormancy. By 2 billion years ago, Mars lost its last liquid water. Though surface water vanished long ago, recent exploration reveals Mars's life story might still be continuing. ESA's Mars Express radar mapping shows massive river channels in Mars's equatorial regions. These dried riverbeds show that late-period Martian rivers were less than 1 meter wide, flowing at just 0.03 meters per second. But 20 kilometers under the South Polar ice, radar echoes caught brine lakes with 28% salinity. This ultra-high salt content keeps water liquid at minus 70 degrees Celsius, providing potential refugees for extreme microbes. In 2025, China's upgraded Zhurong rover drilled clay samples from 3.5 billion years ago. They detected coexisting left-handed amino acids and right-handed sugar molecules. This chirality selection is completely mirror-symmetric to Earth's life molecules. It suggests Mars might have evolved different life forms than Earth. Mars's rapid death actually became a blessing for scientists. Its surface preserved complete geological cross-sections from wet periods to dry periods. Perseverance is systematically collecting rock cores from different geological ages. These samples will build the solar system's most detailed planetary evolution timeline. When scientists used atomic probes to observe nanoscale magnetite in Martian meteorites, they found crystal structures identical to Earth's ancient bacteria. These similarities suggest Mars might have had the same fundamental conditions for life's origins. Scientists reckon Mars had or even has life based on two main things. First is methane gas in Mars's atmosphere. On Earth, this gas usually comes from organic biological emissions or swamp production, meaning it's produced by organic matter. Pretty interesting, eh? The European Space Agency's detector found that in spring 2023, Mars's methane concentration suddenly spiked to 100 times Earth's natural levels. These methane molecules had carbon atoms that were 5% lighter than regular methane. This perfectly matches characteristics of Earth's wetland microbes. But 24 hours later, these gases mysteriously vanished. The exact reason remains unclear. Scientists thought they'd found proof of life, but later experiments showed that soaking Martian rocks in high-pressure carbon dioxide water could also produce this light carbon methane. So this discovery can't definitively prove life exists. The second thing is Curiosity found weird sulphur patterns 3 kilometers under Mars's surface. On Earth, only sulphur-eating extreme microbes show this anomaly, but Mars's data is 8 times higher than Earth's records. German scientists actually cultivated sulphur-eating microbes in Mars, simulating conditions that survive minus 25 degrees Celsius. If Martian life uses perchlorate as antifreeze and sulphur as main food, they might not need water and oxygen at all. It's like suddenly being told cars don't need petrol. Vegemite works too. This completely changes everything we thought we knew. If true, would Martian life be like dormant spores, normally sleeping in salt crystals, then suddenly awakening when conditions are right? These questions really challenge our understanding. Does this mean the universe has a third state, neither living nor dead? Like Siri on your phone. You say it's a dead program, but it communicates with you. You say it's alive, but it doesn't even have self-awareness. Even more incredible, organic molecules from Saturn's moon Enceladus show remarkable similarity to Mars samples. What's the connection? We honestly have no clue right now. Just as we're puzzling over these Mars life signals, NASA's latest reports have put terraforming on the realistic agenda. According to their data, deploying 300-kilometer diameter mirror arrays could theoretically warm Mars's poles by 35 degrees Celsius. But experiments confirmed these ultra-thin mirrors last less than 3 years under micrometeorite impacts. Facing this challenge, MIT proposed an alternative approach: inject perfluoropropane into Mars's atmosphere. This artificially synthesized super greenhouse gas has 10,240 times the heat-trapping ability of carbon dioxide, but simulations show this might trigger 300% more frequent global dust storms. It's like installing an uncontrollable heater in Mars's atmosphere. German scientists have modified blue-green algae that can now break down basalt in simulated Mars environments, but these microbes release chloromethane gas, triggering limits in the Planetary Protection Protocol. This reminds us of Earth's synthetic biology controversies. When we look at human adaptation data, medical studies revealed that long-term exposure to 38% Earth gravity causes vision problems in 87% of astronauts. 3 years of cosmic radiation exposure equals 8,000 full-body CT scans. Maintaining cardiovascular function requires at least 2.5 hours daily specialized training. The biggest challenge comes from nuclear ice melting proposals. Models show this scheme might release 300 times lethal amounts of chloromethane from Mars's crust. This reminds us of Earth's ozone hole crisis. Meanwhile, China's missions propose underground lava tube habitats, attempting to avoid these risks entirely. Fortunately, radiation levels in Mars's underground lava tubes are actually lower than International Space Station standards. This brings us back to the core question. When we find those intermediate substances on Mars, neither biological nor purely chemical, does this hint the universe has some universal pre-life state? Perhaps life's birth conditions are much more basic and universal than we imagined. But NASA's latest data reveals a sobering comparison. Maintaining life support systems for one person on Mars consumes energy equivalent to protecting 542 hectares of Amazon rainforest. Rebuilding Earth-level atmosphere on Mars needs 100,000 years of continuous planetary engineering. That's 20 times longer than humanity's entire civilization history. When we gaze at Mars's orange sky, we should remember that Earth has ecological networks built by 130 million species, plus natural systems from 3 trillion trees. These systems, built through 3.5 billion years of evolution, along with lunar gravity that stabilizes Earth's rotation, together maintain life's foundation. Current human engineering capabilities can't replicate even a tiny fraction of this complexity. As one Mars exploration designer said, "We can simulate Mars environments, but we can't recreate Earth's breathing rhythm. Right now, feel the air you're breathing. Behind that 21% oxygen lies 2.7 billion years of continuous bacterial transformation, stable climate benefits from tidal patterns shaped by lunar gravity. These seemingly ordinary things are actually the solar system's most precious inheritance. So please mates, let's protect our Earth. If we mess up Earth, it might never recover." This is Cosmic Canvas. I'm Star Weaver. If you're into cosmic exploration and unsolved mysteries like I am, then smash that like button and subscribe. See you next time. Love you all. Cheers.